Welcome to the last chapter, the chapter 8, the evaluation of portfolio performance. In this chapter, we will include two parts. From the 8.1, we will introduce the portfolio performance measure. We include 5 different measures: trainer ratio, Sharpe ratio, Jenkins Alpha, Msquare, information ratio, and the last we will compare the difference between these measures. The next part is 8.2, which will give you some extension for this portfolio performance evaluations, which will consider the downside risk and also the attribution of the return or the risk. So let's begin to 8.1 first. First, let's look at the trainer ratio. Trainer ratio measures the risk-adjusted performance focused on the portfolio's undiversifiable risk, which is the market risk or systematic risk. So that's very important point for the trainer ratio. It's considered the market or the systematic risk. And trainer ratio can be expressed as the excess return, or we can call the risk premium per unit of systematic risk. And the risk-averse investor prefer to maximize this value, and this assume a completely diversified portfolio, leaving systematic risk as the relevant risk. So the equation for the trainer ratio is equal to RP minus RF divided by beta P. So the first point, as I mentioned, the important point is the trainer ratio only consider the market risk. So here we use the beta P to measure the market risk. So we only consider the beta P here. And the subscript here, we use P, which means the portfolio. Otherwise, you can use I. You can write like the RI minus RF divided by beta I. No matter you consider the individual assets or the portfolio, it's okay. So you can use I to denote, to substitute or instead of the P. And here we use RP minus RF, which is our excess return, or we can call risk premium. That's the risk premium compared with risk-free assets. So RP minus RF divided by beta P, that's our trainer ratio. The second we will have a look is the Sharpe ratio. Sharpe ratio measure of the risk-adjusted performance focus on the portfolio's total risk. So that's the difference between the Sharpe ratio and trainer ratio. Sharpe ratio consider the total risk. Total risk, we can use the standard deviation of the rate of return for the portfolio to measure this total risk. We can denote as sigma P or sigma I. So in otherwise, based on the equation, we can see the Sharpe ratio is equal to assets return or per unit of total portfolio risk. This portfolio risk is the standard deviation here, as I mentioned. And the third point is the value of Sharpe ratio only useful for comparison with other portfolio. It is the same as the trainer ratio. If you use the Sharpe ratio and trainer ratio to evaluate the portfolio performance, you need to compare this Sharpe ratio with other portfolios' Sharpe ratio, or the same for the trainer ratio. So all these two ratios you need to compare with other portfolios. And Sharpe ratio greater than the ratio for the market portfolio indicates superior performance. So if the Sharpe ratio for your portfolio or for each individual asset is greater than market portfolio Sharpe ratio, definitely it's the better one. And the measure for the Sharpe ratio is the higher the Sharpe ratio indicates a better risk-adjusted portfolio performance. So based on Sharpe ratio and trainer ratio, the higher the better. So that's the conclusion based on these two ratios to measure. And let's have a look at the equation for the Sharpe ratio. It it's equal to Rp minus Rf divided by sigma p. So the difference is now here we use the sigma p, not beta p in trainer ratio. So this sigma p is measure the total risk, include the systematic risk with the unsystematic risk. So that's the big difference between Sharpe ratio and trainer ratio. And the same, you can use I, individual assets, to for this subscript to substitute the portfolio P, this P here. Now let's have a look at the third measure, which is Jenkins Alpha. The Jenkins Alpha measure represents the average excess return of the portfolio above the predicted by the CAPM. So that's the average excess return minus the CAPM expected return. And the superior manager will generate a significant positive alpha. So if the mutual fund manager, they get a higher positive alpha, which means it can earn much more return for their investor, the higher the better. So for the Jenkins Alpha is also the measure higher the better. And the difference is the Jenkins Alpha, they did not require to compare with other portfolios. It compare with itself. So let's have a look at the equation for Jenkins Alpha. The Jenkins Alpha should equal to Rp. So that's the realized return minus the Rf plus beta multiply Rm minus Rf. Therefore, we know this part is from the CAPM. It's our expect return for portfolio P. So Jenkins Alpha should equal to the realized return minus the expected return, which is from capital assets pricing model. And you can also use I to substitute this P in the equation. It's the same meaning here. The next measure I will introduce is Msquare. This M-squared is the difference in the return of mimicking portfolio and the market return. So which means we construct a new portfolio. This portfolio will mimic the market portfolio, and we use this portfolio's excess return minus the market excess return. We will get this M squares. So let's have a look. How can we construct this mimic portfolio? So here we will construct a new portfolio, which we use the P star to denote this new portfolio. This portfolio is constructed based on taking leverage position in portfolio P and risk-free rate. So we invest some money in the portfolio P and the rest of the money in the risk-free assets, and then we construct our new portfolio P star. And this P star will mimic the risk of market portfolio. So the risk for the portfolio P star will have the same risk for the market portfolio. So based on this idea, we will construct our equation. So let's have a look at how can we derive our M-squared equation. So let's have a look at the equation. Sigma P star should equal to WP multiply sigma P plus 1 minus WP multiply sigma RF. So as we mentioned that the portfolio P is constructed by taking leverage position in portfolio P and risk-free assets. So we invest WP% in portfolio P and 1 minus WP this percent in risk-free assets. So we got this equation, and we know the risk for risk-free assets should equal to 0. And the rest is only left is WP multiply sigma P. And we make this portfolio P star to mimic the risk of market portfolio. So here, the final, we make it equal to sigma m. So based on this one, we can derive that WP equal to sigma m over sigma p. So if we know this information, let's have a look what happened for our portfolio return. For the portfolio return, it should equal to WP percent in RP and the rest in RF. And for this WP, we just use this equation to substitute that. We have the following equation, and then we summarize them together. We will get the final result is here. Our mimic portfolio P star, the return for this P star should equal to RF plus RP minus RF multiply sigma m over sigma p. And finally, we get our M square equation. It should remove the RF to the left of our equation. So it is the return for our mimic portfolio minus the RF, total minus the market excess return. So the return for our mimic portfolio excess return should equal to this part. So this is this part minus our market excess return. So the idea for M square should equal to the excess return, the difference in the return of mimic portfolio and the market return. So that's the RP star minus RF total minus RM minus RF. So that's our M square. So you need to remember the final equation for M square. Some students ask me why should be equal to this equation. Definitely you can write down as square, 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 and also you multiply. This is the square, and don't forget you need to plus 2 multiply WP, multiply 1 minus WP, and multiply the covariance between portfolio P and RF. But we also know this part is 0 and covariance part is 0. So the rest part is only this part. So no matter what's the equation for this, I don't write down the full equation, so don't confuse about this equation now here. So that's the M square.